Hi all, this is the latest release video for Nimbra Edge. This is R3.14. So I just want to take you through some of the bullets you will have seen in the latest release notes and take a bit of a deeper dive into what that means for the product and for our customers. So in this release, there are really three main areas of new functionality, new features. The first one is to add PID transformation control for audio and video streams. So this allows us to manipulate our source transport streams to adjust those identifiers that are related to video and audio when we're deriving new sources. We have an extension of the alarm panel and the alarm system to create alarms for low disk space on our worker nodes. And finally, the culmination of a lot of work onto the Matrix Monarch Edge product line, the integration of the S1 box, and also UI proxy support for the entire range E4, D4, and S1. So I'm going to take a bit of a deeper dive into each of these. Some need a bit more information to cover the ground with. Some are relatively straightforward. So here we are. So first of all, let me start with the PID transformation piece. And I know a lot of you will understand more than I do about transport streams, but I thought it was good to first frame what on earth we're talking about when we talk about these PIDs. So as you know, Nimbra Edge transports primarily, or in fact all of our streams that we transport are MPEG-2 transport streams in one way or another, sometimes encapsulated in various different ARQ formats, but at the essence of each one of those is the transport stream itself. And a transport stream has lots of structural properties that enable it to make associations between the bits of media that are being carried, the timing information, and various other important constructions. And so PIDs are identifiers that are used throughout the MPEG-2 transport stream to allow us to identify differing structural components in the system. For us, we're focused on the video and audio PIDs that are contained within the program streams. So an MPEG transport stream has a bunch of kind of overarching structural stuff that's important to the stream, but within it we often talk about a single program or multi-program, and so inside the stream these kind of blocks that are program sections of the stream contain a number of ID descriptors that describe the essence streams and the payloads that are within those. And so for us, in a particular program, there will be one or more payloads for the video and the audio stream. So these could be multiple audio languages, and different programs within a multi-part transport stream. So we're primarily focused at this point on video and audio PIDs. So why on earth do we need to transform this stuff if we've got perfectly good transport streams coming in? And well, customers within our system can't always control the PIDs from the source location. And so, they may need to manipulate that into a structure that's appropriate to them. And we often will have delivery requirements that need to be met at the destination. So in order to adapt the source to a particular customer's facility or to meet requirements of the destination delivery, we must be able to manipulate these PIDs. And the reason that people normalize these or want to manipulate them is you will often drive automated actions on infrastructure within a facility. And so this could be encoders or decoders, or it could even be monitor walls, whereby you want to automatically identify these streams and what they are, and create some kind of action alongside that. So it's important to our customers, especially when they're providing services to lots of different destinations, that we can provide this manipulation. And so there are three operations that we can support in Nimbra Edge for PID transformations. The first one is a mapping. So we call this operation map. And the map will match an input PID specified to a new value. So structurally, this doesn't change the stream, but it allows you to manipulate the values to a new derivative source, a new derived source. So when you're deriving a source, either from a multi-part transport stream, you can choose to apply a mapping to that stream to manipulate any matching input PID to a new output PID. So this allows us to change those PIDs as we map. The second operation is a delete operation. And this will do a match on a PID that you specify, and it'll delete the associated PID and its stream. And in this case, the stream payload is removed from the transport stream, so the overall bit rate of the stream will be changed. So this is useful when you want to create, derivatives that you need to make more efficient from a bandwidth perspective. Let's say you have a large transport stream with a large number of audios and videos. And you want to create smaller output streams, then the delete function will be really useful for that. The last case is a function called null, which does a very similar thing to delete. It matches an input PID and deletes the associated PID. But then the stream payload, the actual data for that stream, is then packed with null packets. So this allows us to structurally maintain the kind of bit rate, and this can be especially important when you're dealing with CBR services and appliances that need a CBR, a constant bit rate stream, to be delivered to them. So a particular use case. You can also create rules that encompass all of these features together. So you could map, delete, and null a particular derived source as you need to. So this gives us kind of a suite of operational tools that allow us to play with those transport streams and the PIDs within them in order to meet the requirements, either internally in the Nimbra Edge system or for different delivery requirements that our customers might need. The next feature is a network manager enhancement in many ways. Of course, it's back end, but from a customer's perspective, they'll be interacting with this in the front end. And these are low disk space alarms. So the worker nodes within the system are now monitored for disk space thresholds, and the alarms are generated if these thresholds are breached. And so that allows kind of more reactive actions to be taken before the performance of a worker node is compromised. So you'll see in the alarm panels and the history, we now have these storage threshold alerts, which will give you an alarm warning if a device breaches that threshold. So this may enable our customers to make decisions about adding additional worker nodes. It's indicative of a system that is probably becoming highly utilized, of course, or it might be needing to expand the underlying disk space and so on that's attributed to the node in the system. But the idea here is it's proactive monitoring and alarming before problems are created by overutilized storage on these worker nodes. So pretty simple addition, but very important to the resilience of the system overall. And then the final feature here is the Matrox appliance support. So we've been focused over the last kind of 4 months on a particular product range, the Matrox Edge product line. It's been driven out of requirements from, I think, a particular service provider customer to increase the available support for Edge devices. So there are 3 Matrox products that we now support, and they all sit within this range. They're little half 1RU boxes. And that's the E4, which is an encoder, the D4, which is a decoder, and the S1, which is a hybridized encoder and decoder in a single unit. Some things to bear in mind when you look at the supported appliances. This is a 422 10-bit appliance. It's a higher end appliance than maybe the Videons or even the 400. It supports 422 10-bit encoding and decoding in the range, as well as some higher end uncompressed I/O options. So it supports SMPTE 2110 for I/O, as well as 12G SDI when dealing with 4K on a single SDI connector. So so our customers that are looking at higher end interactions with uncompressed 2110 infrastructure or 12G 4K SDI, this provides a good tool for that job. As part of that integration as well, we've also included the ability to proxy the UI. So this is allowing access to the Matrox configuration UI via the network manager. This is a similar feature that we have for the 400 range of our own devices. You can click on a link and it'll open up um, the the native UI for that device. So these are quite well integrated appliances within within the Nimbra Edge system. Just a quick note on this as well. Performance of Edge Connect devices when they're used as part of the Nimbra Edge ecosystem, we obviously have to run more services on them to provide that integration. They can differ from the OEM datasheet, so it's important that you do talk to the product team for advice when you're discussing these integrations with customers. It's a process where we're benchmarking at the moment the performance of these devices and the functions that are available when you use them with Nimbra Edge. So don't just take the data sheet verbatim. When you're talking to customers, we do need to discuss the use cases and make sure there aren't any problems there. But yeah, this is a kind of another appliance that you can use to get signals in and out of the Nimbra Edge environment. So should extend our reach a little further for some of these higher end applications. That's it from me. A quick update. If there are any questions, then do please either reach out to me in the sales business development team, or of course, discuss with Urko in the product team if you have any questions on anything we've discussed here. Apart from that, thank you very much, and I'll be in touch soon with the next release. Cheers, bye.